So for the code part of this, we want to make it so that way our health is affected by this button, and then when this health goes all the way down, we get you died. And we want all of this to be affected by 3 different timers. When you hit the button, we should slowly start losing health. Then it'll maybe lose a couple health, like it's a poisoned status effect or something. Then the button will have like a toggle, and then when the timer is done, the button will turn back on. And then finally, it'll say you died, and that'll be it. So what we're going to do, on our canvas, we're just going to create a script, and we're going to call it in-game UI. Now notice how I don't actually have a player script. You don't need one, but please listen carefully if you are not confident coding, because not everything should go in the in-game UI. Some things make more sense to go in player. Okay, just configure it quickly. So, first things first. First things first. We need to configure our variables, and there's a bunch of variables whenever you're working with UI. So first of all, let's just take a look. We need to know this piece of UI here. We need to know the fill amount on this image. So we need an image variable for our health. And then we need another variable, 2 actually, for our health variables. And not all of these should be in here again. So serialized field, private image. And when you import image, be very careful here. We want unityengine.ui. And we're just going to make an image. We're going to call this more specifically our health bar. Okay, then we're going to create 2 more variables. And again, this should not go in in-game UI. 9 times out of 10, it makes 0 sense to put this in in-game UI. We're going to make 2 variables. We're going to make a private int, because in Minecraft it would be an integer, not a float. But you could do a float if you wanted to as well. And we would say max health. Give it a value of 20. You could do serialized as well if you would prefer. That it would make it a little more flexible. Then we can do another serialized. Actually, this one shouldn't be serialized. We're going to make a private int, and it's going to be called current health. Okay, and then it wants to have an underscore because it's a private variable. And then in start, we're going to say that current health is equal to max health. Now, in C#, there's a very, very cool thing that you can do. And this is a more advanced technique, but it'll make your life easy. When you say current health equals max health, this is pretty common, and it's assigning your variable. But let's say you never want your developers to be able to make this mistake and not affect the UI. Because if I just did this, the UI isn't being changed at all. It's not going to do anything. So what we need to do, or what we can do, is we can say get private or get set, just like this. So current health is now a get set, and because it has these auto properties, it actually doesn't want to have an underscore anymore. In fact, it wants to be capital, because this technically makes it into a function. Next, instead of set, we can delete this semicolon and add squiggles, just like this. And then inside the squiggles, we can, well, set our property. So what we can do is we can say health bar, and then dot fill amount, right? And fill amount is this property over here, the fill amount, equals, and then we want to do the current health, so it will be the value divided by the max health. And then the value, it says that this is going to be cast to an int, and we're going to have loss of fraction. Let's tell it that we do want that loss of fraction. Actually, I guess it doesn't matter. Loss of fraction. Yeah, and that's good. There's an issue though. It's not going to remember our value, so we do need to make another one. We're going to make a private int current health again, and this is not the one that you should change. And we're going to say current health equals equals value. And then in the get over here, we're just going to get current health. Okay. Great. So current health with the capital is the one that we actually want to use. And then whenever you change it, it's going to automatically be bound to our health bar and update appropriately. Now, most health bars are not integer based, so you could make this a float, and you can see that that is also the warning that I'm getting here, that it's warning me that this is probably going to be loss of integer, which is, again, fine in our case. Actually, no, it's not, because the fill amount is a float. So we do need to cast to a float. We could say current health divided by max health if you want to be more specific. And there you go. Let's actually test this quickly. Let's say that current health is equal to max health, and then divide by 2. Okay, and let's test it. So on my canvas is where I've attached the script. I'm going to drag and drop in the game object, which is our mask. Let me rename this to mask. Okay, and then I'm going to say the max health is 20. So you should see that it's only filled up halfway. There you go. It's only filled up halfway. So this is automatically going to sort out our issues for us. The next thing that we need is context for this. And we need a function, yeah, we just need context for that. So we need to know our disabled UI, because it has a filled percent. This is the main thing. And I'm not sure if we need the button. If we do, we'll come back to it, but it's just not coming to me right now. So let's duplicate our other image, and this is going to be the damage bar, and then, yeah, that's probably it. We need one more. We want this text. Actually, we do need the button. I'm remembering now. We do need the button because we want to be able to disable the button. So we need a serialized field, private button, and it's going to be damage button, and then one more serialized field, and we're going to do a private text mesh pro UGUI, and it's going to be our death text, which is the text in the center of the screen. There you go. And now, really quick, because we want to avoid mistakes down the line, let's go back into Unity, and let's assign these variables: the damage bar, and the damage button, damage disabled UI, and then the text, and that's all good. You died. Okay. Next, on our disabled text, what we're going to do, let's change the vertex color down to 0 so we can't see it. And then this is ready to go. On our disabled UI, change the fill amount down to 0 so it's not activated. Go to the damage button and make sure that it is interactable on. And then our scene is ready to go, as we're ready to actually implement stuff. So back in the code now, we need to start setting up our timers. Now we're going to do 3 timers together, but the setup for every timer is exactly the same. We're going to say private IEnumerator, private because only we need to access this, and then IEnumerator is our timer, and then you give it a name. So this first one is going to be, let's call it a poison timer. I spelled poison wrong. Don't worry about it. It's a known fact that programmers can't spell. Please, 1 second. Okay, I got it. Don't worry about it. And then you're going to get this error. It's because you said IEnumerator instead of void. So all you need to do is say yield return null. And we need 3 timers. We need one for the damage button interaction timer. Damage button interaction timer. Which is kind of a terrible name, but oh well. And let's do one more. It's going to be the death screen, and then, yeah, just death screen timer. So that way we can have a nice transition in. Okay? Now, we're going to talk about 3 different ways to do timed events. Yeah. So what we're going to do, let's create a bunch of variables. First of all, let's make a private int, and let's call it poison damage, and then, yeah, poison damage, and let's just set it to 1. And let's just make this constant. Private constant private int. Why is it? That's embarrassing. And I spelled poison wrong again. Okay, whatever. It doesn't really matter. It's just we're creating a variable so that way it's easier to read down the line. So poison damage is equal to 1. Let's create a private float. I don't know why I was putting const on the other side of the private. I am sick, that's my excuse, but to deal with it. Anyways, private float. This is going to be a poison damage per second. okay? And then we're going to talk about a bit of optimization here. When you're working with timers, there's many, many ways to do things. So what we're going to do, and actually, you know what, let's come back to this. Let's create these two variables, and let's start with just our first basic setup timer. Let's make another variable. This one's going to be serialized. So is this one, actually. No, it's not. This one's going to be serialized. The other one won't. Private float. And it's going to be the time between poisoning. Why not? Goodness. And you can see how Unreal convention is confusing me, because in Unreal you type differently. Anyways, so with this, what we're going to do is in this function over here, we want to have our timer. So we're going to say private float, not private, just float current time, starting at 0. So the current time is starting at 0, while the current time is smaller than the time between poisoning. Let's create the percentage. Float remaining percent equals 0, and then not equals 0, equals current time, cur time divided by, and just like you would do with your grades, you divide the grade you got by the max to find your percent. And then what we can do is we can say that our damage bar here, damage bar dot fill amount is equal to remaining percent. But there's an issue. Cur time is always 0. So what we'll do over here is we'll say cur time, and this will go forever if you were to just try this, by the way. Cur time plus equals time dot delta time. And there's another issue. This isn't going to work. In fact, it's going to run once. It's going to crash your computer for like 5 seconds, and then it's just going to finish. That's because we need to say yield return null. Yield return null means wait until yield return new frame, next frame, null. There's more things here, but yield return null is the main one. And we can actually remove this one here from the bottom now. So that would be the full function. But we also want to make sure that our button is interactable correctly. So what we'll do is we're going to say up here, our damage button. So what did I call it? Just, yeah, damage button, interactable. And let's set it to false at the top, and let's set it to true at the bottom. So when this function is called, we're going to stop the button from working. We're going to do a timer so that way we get that little effect on the screen. And then we're going to make it activated again. As easy as that. Okay, so now if we go back into Unity, and you go to your damage button, on click, it does nothing. So let's press plus. Drag and drop in your canvas, because that's the object with our script. It might not be your canvas. Whatever object has your in-game UI script. For me, it's the canvas. And then from no function, in-game UI, and oh, it's not here. So if you want to be able to call a function like this, you would make it public. But then there's another issue. Right? And then you can see that it still doesn't show up, or at least it shouldn't show up. There's another issue. That's because it is a coroutine. Now, coroutines are timers, and the way you actually use them is very special. So we don't want to do anything in here. Instead, what we want to do is put this back down to private, and we're going to make another function called public void set poison timer. Okay, and then this one, called in Unity, is what we want to do with it. And what we're going to do is we're just going to start a coroutine for our damage button interaction timer, just like this. So we're going to actually start taking damage on our button. We're going to toggle our timer. Then, let's do this again, start coroutine, and we're going to start our poison timer, just like this. Great. So now let's go back. And the button has gone black for some reason. There it is. Okay, great. And now, on this, we can say canvas, in-game UI. There it is, set poison timer. And when I press plus, when I press play, and then I press on the timer, nothing happens. Why did nothing happen? Nothing happens because I'm a clown and I made the biggest mistake you can make on canvas. And then the poison time is 0. So of course the timer is not going to work because there's 0 seconds on the timer. Again, I'm sick, that's my excuse. So we're gonna make it 3 seconds for our cooldown. And then when I press play, and I press the button, and there you go. Except that's not how that should look. That looked really dumb, right? It's like it's going the wrong way. So it is. What we need to do is instead of starting at 0, we start at the time between poisoning. And then we increase this to greater than, don't increase it, just change it, and then greater than 0. While the time is greater than or equal to 0, decrease by the time passed, and then take the remaining percent. The current time divided by the time between poisoning. And now it'll go the other way. We love numbers. Other way. There you go. And you'll see that it turns on. That is much better. And you can see how you can integrate this into your UI. And again, if you're clever with your masks, very easy to use. Now the next thing is the poisoning timer. So we did a basic timer, except this isn't always the best way to do things. For a poison timer, we're not doing things in floats where every single operation matters. We're doing things after a certain tick limit has been reached. So we can optimize here. Or before we optimize, we need to discuss our plan of attack. What we can do is we can create a while loop. While circle squiggles, and we can create an int here. And it's going to be called, well, we already did, poison damage. Let's make it serialized. Serialized field, poison damage. And then you can give it a value or something, give it like 10 or whatever. And what we can say, 10 is a lot, just 4. And then what we could say is while, and then let's make a variable, int remaining damage. And then let's set it to, I don't know, 0. Let's just set it to poison damage. I don't know, it's easier, it doesn't matter. Poison damage. Remaining damage is greater than or equal to 0. Decrease remaining damage by 1. And then take damage. Right? So you can choose how you want to do this, but we're going to decrease the remaining damage by 1. Then we're going to set the current health minus equals 1. And then we're going to say yield return new. Wait for seconds. And then in here you can put your seconds. Let's say it's going to wait 0.2 ticks, just like this. Okay? Many ways to do things. I'm just trying to show you all of your options. And now the reason why we did it like this is because this is going to be much more optimal than doing it every single frame. This is waiting until a thread is done, so this is going to be a little cheaper. Now, there is a problem. We said the word new, and new you want to avoid at all costs. A good programmer avoids new, and it's a really easy thing we can do here to avoid new, but it's a trade. So ask yourself, is this going to be constant? Yes or no? If the answer is yes, then there's an optimization you can do. If the answer is no, then there is not. Right now it is constant, but if I wanted to add this, let's say I made this poison damage per second, and I made it serialized, and I put it in here, well, then that's not constant, and therefore, this is fine. That being said, if it was constant, let me show you an optimization you can do. Again, minor optimization, but optimization nonetheless. We can say private static, read only, and then it's going to be a wait for seconds, and let's call it time between seconds, or time between poisons, time between poison, equals new, wait for seconds, let's do capital T because it's static, poison spelt wrong as always, and then it's a function call because we're making a constructor, and then you pass through your time. This is more optimized, and you'll see that writer's actually saying you don't need to explicitly declare that, but it's a habit. And there you go. So now we've only actually said the new keyword once. Only ever once in our code. And this will happen as soon as you press play. Instead of down here, when it would happen every single time you take damage, we'd say new. Now realistically, you're saving like 200 bytes, which is so astronomically low, it doesn't matter. Stop stressing about this kind of thing. I don't know why I do. It's something to keep in mind, but it's not that important sometimes. If you know it's going to be constant, you may as well do this. So I'm going to do this. I'm just going to say yield return and then time between poison. You do not have to. It is very extra. And then there you go. Now the poison timer is ready to go. Let's quickly go back to start and let's remove the divide by 2. So now when I press play, and I gave the thing a default value, right? So it's not, yeah, it's 3. Oh, that means I'm going to lose half a heart. Wait, is that a different variable? No. Wait, did it save? Poison damage is 1. What is time between poison? Oh, it's this. That's something else. Okay, sorry. Goodness, I suck at naming variables. So now when I press play, you can see, there you go, I lose my 2 health every 0.2 seconds. Let's increase the poison damage to like 4. There you go. Although I'm seeing that there's an issue. It looks like this shouldn't be greater than or equal to 0. It should just be greater than 0. Because it looks like it's decreasing it one too many times. Let's decrease the poison damage, or increase it to 6. So we should lose an entirety of 3 hearts. Great. And then let's put this down to 0. Not 0. We can't have 0. Let's put it down to like 5. So we should lose 2.5 hearts. Excellent. Many ways to do things. And you could also have it be based on a timer instead, so it's not on this. Now let's say we want a way to be able to cancel our poison. I just thought of this right now. Maybe you want to be able to do that. So what we can do is we can make there's many ways to do this, actually. Here's one way. We can store a reference to our coroutine. This is probably like the safest way to do it because it'll work every time. We can say private coroutine, and let's call it is or poison routine. Poison routine. Okay. Now, let's make a function that's called public void stop poison. And we're going to say poison routine equals, or we're going to say if poison routine is not null. If we're currently being poisoned, then we're going to say stop coroutine, poison routine, and then poison routine is null. And then we actually need to assign poison routine at some point. So over here, we would say poison routine equals poison timer. And then for the sake of just showing you guys that this would work, I'm going to quickly just create another button and make it green. I'm too lazy to actually make this work fully, but button, whatever, it's green. Whoops, I forgot to set it up correctly. If you wanted to make the UI for it, you could. But with this button, instead of set poison timer, it's going to be stop poison. And you don't have to do this. I just wanted to show you that this is a thing we can do. Stop poison. And so now when I press it, I'm losing health. And then I can stop the poison, and it'll stop. Actually, I only lost 1 health there. Hold on. Canvas. Poison damage is, let's say it's 20, so I'll lose all of my health. I press the button, and then stop the timer. There you go. You can see that it stopped. Cool. So that's how you can stop a coroutine. Finally, we have one more example of a coroutine, the death screen timer. If our health reaches 0, then, well, we should die. Pretty straightforward. So what we're going to do is in here, and again, many ways to exit a coroutine. Here's another way to do it. What we can do over here is after our timer, before we continue back around, or I guess you could do it over here. We'll say if the current health, sorry, don't use that one. If the current health is less than 0 or equal to 0, then we must be dead. Right, that's pretty obvious. So what we'll do is we're going to call another coroutine, and we're going to stop our coroutine. So we're going to say start coroutine, and we're going to start our coroutine on our death screen timer. And then we're going to yield break. Yield, and then break stop. Wait, stop. Done. It's going to kill itself. That's it. There is one more thing that's occurring to me right now as well. You're probably thinking, oh, I can implement these timers on so many things, like a health pack or something. Be warned, when you make your timer, whatever object owns the timer, my in-game UI can set the poison timer, because it belongs to the in-game UI script. The timer will be placed on whatever you start the coroutine on. So for demonstration purposes, let's say for whatever reason you want to delete the owner object of this script. Okay? you can say some other object. So let's have a reference object here. You could even say death text dot start coroutine. And this way, the timer is running on the death text object. So as long as the death text object is alive, the coroutine will run on that object. It doesn't matter if I am alive. So again, if you are making a health pack and you destroy the health pack, do not start coroutine on the health pack. Start the coroutine on the player. Okay, the code can be on the health pack. The coroutine should be on the player. Moving on. So, if you have a question about that, you can ask me on Discord as well. But so, finally, the death screen timer. Let's say you want to make a really quick effect where it's not linear. It'll come in like after some time. So what we'll do is this really, really easy to do. We're going to create a serialized field, private float, and it's going to be called the death animation time. Let's do another one. Serialized field, private animation curve, and it's called an F curve in Unreal, and they're just really, really nice to work with. And let's call it just death anim curve, just like that. Great, so now let's scroll down, and we're going to set up another very simple timer. So we're going to say float current time starting at 0, while the current time is less than the death anim time. Increase the current time by delta time, by the time passed. And almost every timer is just going to be that, by the way. And then inside of here, wait until next frame. Then, let's get the percentage. Equals the current time divided by the death anim time. And then, we're going to sample our animation curve. So we can say death anim curve, sample, or dot evaluate is what it is, and evaluate the percentage of our animation curve. Okay, and this is going to give us back a float, and it's going to be a value between 0 and 1, see a float, a value between 0 and 1, that is going to be our alpha value, how quickly it's going to appear. So what we want to do, at the top here, let's create a float, and we're going to do a float, start alpha, and it's going to be 0, and then a float, end alpha, and it's going to be 1, and then let's create a color, and it's going to be the current color. We're going to set it equal to, and then it's going to be death text dot color. So we're starting at this color. Let's actually change this. Our starting alpha may as well be the current color dot A, and that way it's just more correct, just in case, but it doesn't actually matter. So now, with our starting color, we're going to say starting color, or sorry, we're going to say that death text dot color is equal to current color. And again, I'm avoiding the new keyword here. So there's actually two ways you can do this. You can actually say equals new color, and then you could say whatever. You could say current color dot R, current color G, current color B, and then your start or your death anim percent. Sorry, it would be mathf.lerp. We're lerping between the start A, end A, and death anim percent. And I can't really explain to you in this time, percent, here it is. I can't really explain to you in this time what a lerp is, but pretty much if you sample 2 points, your starting and your ending point, we say that this is 0 and this is 1. And then you can choose a percentage between here. So like 20% would be here, 50% is here, and 100% would be all the way at the end, of course. This would be like 70. That's the idea, but straight. So we're lerping between these values. Now, because you're saying the new keyword, this is actually very bad, and this would be a rookie mistake, because there's an easy way you can make this better. You would say current color equals, and then we don't want to change the current color entirely, because if you look, we're only changing the alpha. So current color dot alpha equals mathf.lerp, because that's what we're changing. And then all we need to do here is say current color. And there you go, no new keyword. We're saving like 400 bytes of data Why not? That's probably a little bit more than it actually is, to be honest. It's not 400 bytes, but you know, it's something. It's worth thinking about, and it's part of being a good programmer. Anyways, this is ready to go at this point. So back in our canvas, let's quickly change our variables. Our def anim time will take 5 seconds to animate, and then we can have a timer. It's going to work like this, just this simple preset. It'll start slowly, and then it'll come in quicker. Or let's actually change it to be like this. No, like this is better. So it'll slowly fade in, and then it'll fade in a lot quicker. And just like that now. Let's change the poison damage to be 20, so it'll kill me. Let's quickly just showcase this. So when I press this button, you can see that a timer goes on, and I can stop the damage. And then I can press it again, and I will die. And when I'm dead, you died. And you'll see that it slowly fades in as according to this timer and the time that I've set here. Very simple introduction to timers and pretty much everything there is to timers.